Hello and welcome to another episode of the AI Show. How's it going? Can you believe it's already December? What kind of nuttiness is that? My name is Seth Juarez, and I like AI. So I thought today we would do a little bit of AI stuff-ish, if you will permit me. We have a wonderful show for you today. In fact, let me get my board out here so we can discuss what we're going to talk about, and you can choose the things that we should cover. So let me share my screen here. Here we go. Share my screen. Here we go. First of all, tell me where you're from. I'm excited that everyone's here. As I get stuff going here, just in the chat, tell me where you're from, and I will say hello, and then we'll talk about what we're going to do today. Today, number one, we are going to look at a visual, I'm going to try to write nice today, visual search toolkit with our friend Serge. He is a delightful person, by the way. Delightful. So we're going to talk about that. He could not be here, unfortunately, because it is in France. 11, 12, 1, 2, 3, 4, 5, 6, 7 p.m. on a Friday night. So honestly, you probably don't know this, but backstory to this show. Oh, number 2, by the way. I wanted to do this show on a Friday in the middle of the day because, middle day Pacific, but Friday, after everyone's had a long week, we could all relax together and learn some cool stuff. So that's why I did Friday. Happy to change it, by the way. I'm not married to Friday. Incidentally. Number 2, we have some options here. The first thing is I'm behind on some work. So I thought I would do some work. So I actually made a data generation library. Because the reality is, anytime I make demos for machine learning, it's hard. Because we need data. And so I think it was at Microsoft Build, this was probably in May, I built a quick library that generated some data according to specific mathematical properties that made it easier for me to show stuff. So we're going to look at this. This is in a state of disrepair. So we'll go in there, I'll explain it, and we'll make some fixes. Number two, we'll go back. There's this idea that we can go back to Rochambeau. Remember, we left off last time where we were working on collecting more data so that our model could be even better, so that we could have the end-to-end sort of model stinks. We give it more of our data, then it goes back into the model, and we'll have that sort of refreshing. And then everyone else can submit images. I need to talk to our lawyers about that, but still. I might just put a disclaimer. This will be used to train a model and might be shown on the AI show, so nothing untoward. Honestly, we might need to put a cognitive service in there just to make sure no one's putting nasty pictures, if you know what I mean. And then the last thing I was working on is I'm redoing my blog because I wanted to write a blog post, which means I need to redo my blog. So I started working on that yesterday. So these are our options. Number one here. Number one, number two, and number three. Vote, please, on which ones you think we should be doing after we do the visual search toolkit. Number one, number two, or number three. Totally up to you. All right, let's see where everyone's from. Hello and welcome. From Iran. I love Persian people. Persians are the best. Heck of a soccer or football match we played. What a wonderful team y'all put out this year. Argentina. Ivana, ¿cómo estás? Qué placer. Another wonderful football team as well with Messi on there. I like football. The one that everyone calls football. By the way, we're still voting on number one, number two, or number three. So hello, everyone. Hello, TC Coder. Welcome to our humble show. Welcome. Uh-oh. Janiscu, number 7. Hello, sir. In the dusty halls of my Twitch. Thank you, sir, for coming. AI data, yeah. That's a vote for number one, I think, right? Number one. So number one, number two, or number three, you can choose for the second part of our show. Just put it in the chat there. I will look at all of your votes, and we'll do that. But for sure, I think we're gonna do number one, because like I actually released a pip package on this, and I need to use it again because I want to do some experimentation with data drift, and I don't know. I feel like I could use real data, but then I wouldn't know what the exact drift is. But if I generate my own data, I would know the variance in the distributions of the data that are coming, and I can tweak them slightly to generate alerts, which is nice. And then Rochambeau number 2, which is a more image collection. It feels like this has become more of an exercise in writing React, because ultimately all software ends up being JavaScript. This is where we are, people. I didn't make this up. It is what it is. All right, but before we get to all of that, it's time to talk about the Visual Search Toolkit with Serge, mon bon ami. By the way, I love France. France is just a lovely country. Every time I speak French there, though, they speak to me in English because I guess my French is awful. It's true. My French is awful. But it's okay. I'm okay with that. At least I can be understood. All the JavaScript, indeed. All right. So, again, for the second half of the show, you can pick between number 1, number 2, or number 3. Should we continue on this? This is a new one. I actually am experimenting with putting out content. So I can do that during the last half. But now it's time to pay the bills. Let's talk about Visual Search Toolkit with my good friend Serge, who is awesome. Let's go to that You're not going to want to miss this episode of the AI Show where we're talking all about a visual search toolkit with Azure AI with our friend Serge. Make sure you tune in. Hello and welcome to this episode of the AI Show. We're talking all about the visual search toolkit with Azure AI and our friend Serge. Serge, how are you doing, my friend?
Hello, comment ça va?
Tout va bien aujourd'hui. For those that don't know you, why don't you introduce yourself?
Tout va bien. Yes, so thank you, Fef. So just a quick presentation of myself. So I'm working for Microsoft. I am part of a EMEA GBB team dedicated to AI technologies. And I'm very happy to be today once again with you to present some great things about our AI technologies running on Azure. And today it's all about Visual Search Toolkit.
And we really appreciate having you on because you actually make stuff with customers. I make a lot of demos, but you make stuff that actually is super useful. And we're talking about visual search. Can you explain the problem a little bit for those that are watching?
Yes, so I mean, we are all using search on the web, using some technologies to find out some information or documents or whatever. But now we have some brand new capabilities using AI to use not some keywords, but to use an image. So think about to make a query, not using free text, but using image. Let's say you have a nice product and you want to have much more information on the product you can see in a store, in a shop, or whatever. Just take your smartphone, take a picture of the product. You will have an image, of course, and then you can find all the similar images. So that's the goal of visual search technologies. We will use AI technologies, of course, because it's not about text, it's about an image. And we will use AI services running on Azure with a nice technologies to manage all the queries, which is Azure Cognitive Services as well.
So that's cool. So if I'm understanding this right, we're basically creating a search toolkit where instead of typing in text to find a thing, you take a picture and it finds the things that are like that picture.
Yes, correct. So we will use a picture. And by toolkit, I mean, I will share with you at the end of a quick demo a link with a collection of Python code that you can use in every companies, every organization, or if you just want to play with it, you will have all the great code I made. Hope it is great, but it will do all the job for you if you want to test it on a typical use case. Everything will be almost ready for you.
I love it. So basically, not only are you going to show us the technique of how it's done, but all the code is available for folks to download and use whenever they want.
Yes, of course, you will not have 100% of all the code ready, but most of it is there. Just bring your own images, okay? Just use in sequence all the different Python code for doing all the pipeline creation and the pipeline ingestion. And at the end, in almost no time, you will be ready to do some testing.
Awesome. Well, can we take a look?
Yes, so let's have a quick look. So it's just a part of visual search using Azure AI. So in this use case, we will work in a retail, in the retail industry. Okay. So you will see a collection of Python code stored in Jupyter notebooks. You will have notebook number 1, number 2, number 3, and so on. And let's have a look at the first one.
Let's do it.
The first one is just a collection of multiple steps to use some to display some product images. So think about a retail industry. And let's say you have a collection of catalog images. You can see some of them there. You can see some French names in it, some English terms in it, and so on. So we have a collection of field images. By field images is what you can take from your smartphone. You can take an image. Let's say you're in a shop and you want to have much more information on this product, or it can be that one, or that one. So this is the first part. The first part is just to make some connection to your catalog product images and the field images you can have. Then the second step is to be able to switch from images to text. And for that, we can use many kind of technologies for that. The one I was using was OpenAI using sentence transformers. What is the goal of OpenAI? And this capability is called OpenAI Clip. OpenAI Clip model will allows you to take one image, okay, and to save it as with a collection of text item. And then we will be able to use these technologies. So the first step that you will have to run is just to index all your catalog images using OpenAI Clip, and then you will have some vec text. Vec text is just the outcome from OpenAI Clip using your catalog images. And we can do this for all your model. Okay, it will take a couple of minutes to achieve. And what you can see there for all your catalog images you can have about all your products. In this case, I have image 1, 2, 3, and so on. You can see there a vec text. What is a vec text? Is a huge number and text that will define somewhere your image file. And this is what I will save in order to make a search later on using one image. Okay.
So I have a
So the
question.
first step
So,
is just to do this vec text information.
so the question I have is, if we go back to step number 2, this is the part that was a little confusing to me. We're using OpenAI to merge together some images in our catalog with some text that's also in our catalog. Is that right?
Yes,
I see. And so we're using those two things put together and then storing those in a textual representation, which would be this vec text.
exactly. At the moment, this is one input I have. And of course, the vec text information will be saved into an Azure Cognitive Search pipeline. At the moment, I am just going to create the index, and this is just the first part. Okay.
I see. So what does the part when I'm doing the searching, I'm going to give it an image that's going to put it into the same space without the text. It's the text is the part that's confusing me.
Yes, yes. And I will add much more information for each image,
Oh, I see.
because as you can maybe imagine or understand, in some image you can have some barcode information. Okay,
Mm-hmm.
especially in the retail industry. What is a barcode? Let's have a look at this product. As you can see, there is a collection of text, and of course we can use Azure OCR technologies to retrieve the text. But in this case, let's have a look at the barcode. I have a Python code there where I can detect the barcode, and I can read the content from the barcode or the QR code. Okay, so I have additional information, not only the image itself, but the content that I can have in my barcode or QR code.
I see. So
So
you're not just storing, oh, this is clever. So you're not just storing the image, but you're storing any text or barcode information or anything that's in the image,
that's
and you're
it.
putting it into this vector.
Exactly.
Oh,
So
okay.
I'm going to do this for all my catalog images. It took 12 seconds. It's quite fast because with Python you can do some concurrent execution and this kind of things. So it's very fast to analyze my 466 images and to retrieve every information. Each time there is a barcode. Maybe sometimes I don't have any barcode. Sometimes I can have barcode. Okay, that's it. As you can see, for this image, I have a barcode text. Okay, so that's one additional information. I can have much more information using Azure Read API for OCR or Azure Computer Vision to detect automatically some colors, caption, and tags. Let's have a look at this French product, as you can see with the title, the French title in it.
Mm-hmm.
This is the OCR outcome, okay? Just using Azure OCR to retrieve any text from the product. But I can use as well Azure Computer Vision to have the main colors. Maybe it can be useful when you have a product to get some colors, to have some tags or caption, a box of cookies. That's correct. This is a good results based on this image. Let's have a look at this product. We have some Spanish words, English, Arabian, Asian as well. I can retrieve everything and I have a good description.
That's
So
cool.
this is just to collect any kind of information from one image to my Azure Cognitive Search pipeline.
And that's clever because you're augmenting the image with any information you can pull out of it so that when you do the search, you're going to get exactly what you want.
That's it. For example, let's have a look at the colors. For each image, I have the main colors. For each image, I can have the tags coming from the Azure Computer Vision. I can retrieve the caption as well, okay? So that's the thing. So, and then I have everything to create my Azure Cognitive Search index because I have the vec text coming from OpenAI clip to turn my image to numbers and text. I have all the OCR coming from the process I made before. I have the barcode or QR code information. I have the main color information, the automatic tags, and so on. And now we take everything, okay? I will consolidate everything and I will ingest everything into an Azure Cognitive Search index. So this is what we did, okay? We are using OpenAI vectex first, the OCR, all the results, the barcode, and then we will try to consolidate everything into a cognitive search index. Okay, so I have a cognitive search index there. You can see it. It's called demo retail. Okay, and I have all the fields I will be able to use. Okay, then it's time to play a little bit with my index because my index is there and I am able to use it. So let's do a quick test. Okay. And let's take this example. Okay, I will zoom a little bit. Okay, let's say this is a field image. Let's say you're at home in your kitchen, you take a product, you want to have much more information on it. Or you are in a store, you want to have additional information on a product, just use your smartphone, nothing else, just a picture. So this is a field image, that one, okay? Let's call the cognitive search index, and this is the outcome of a search.
That's
So
amazing.
on the left, you have a field image, the one you took in a shop, for example, and then you have the similar image number one, then similar image number two, number three, and so on. And that one will display the catalog image number 61, and so on. And this is the same product, of course. Okay. Another example. Okay, so this is a tomato soup, I think. Okay, so this is a field image, another test, and this is the same product. Same product, same product, same product. Not the same product, but that this is the product that came number 5. Okay, so but the top similar images are correct. Let's take that one. Okay, I took this picture at home and I can find all the catalog images on the same product. And this is great because think about a company that would like to set up a spare part recognition project. Okay, when you just have a product and you don't have any text in it, just the image. You can take a picture of it and see, okay, this is product number 1, number 2, or number 3. Another example, that one, okay, and you can see all the similar results coming from it. Another example as well, we know the brand, okay, and we have all the same product there. What you can do as well is to play a little bit with some text. Okay, let's say you have this. You just specify your text. Let's say it's a serial number, for example. Okay, and then the outcome of the Azure Cognitive Search is this full outcome. You have the JPEG file, the product. You have the OCR, the barcode, colors, and so on. And this text is the barcode number. So you can make a query on your catalog images list, and well, you will find, of course, all the results. And then you can display all the similar images. And this is the same product as well. And last example, you can combine OpenAI Clip, Read API, computer vision, barcode, everything into a single query as well, not using only the image, but all the additional extra information. And then you will have all the similar products in a list, or just using a specific view. And this is always the results. First catalog images, that one, and that one. And same thing for that one.
I mean, this is
So,
this is amazing. And sorry, you were saying.
no, I was just saying that, and this is the end of the demo. Of course, you can have a look at the specific link that I will share with you in a couple of seconds.
Right
So
here.
it's
I
called
put it up
Azure
for
Visual
us.
Search Toolkit. Okay. And you will have all the description, all the documentation, and all the notebooks are there. And you have some images if you want to try to play with something, even if you don't have a collection of existing images, there is something to start. And you have all the notebooks there, so, and all the Python code uh, that you can use, and it's ready for use, and it's ready for you.
This is so cool. So if we could summarize, because I think I'll put the repo up at the end. Can you scroll down so we can look at the process? Because I think the process, because we went really fast. There's a ton of, so when you say Visual Search Toolkit with Azure AI, you literally mean a full gamut of AI services. So just quick bullet point, what are the services that you use, and then how were they all put together at the end with the index?
Yes, so let's have a look at the services, okay? So what you can see here from step 1 to 8 is a full process.
Right.
When I did the demo, I took an image, okay? And so this is my reference image file, and I want to have a list of all the similar images that looks like this
Right.
reference image, okay? So for that, in order to switch from one image to a collection of text, I will use the vectext generation. Okay, for that I am using sentence transformers, which is just a Python wrapper for OpenAI Clip. Okay, so this is just a way to switch from the image view to the text and numbers view. So this is one step. The second step, in order to add much more information during the search, is not only to use the image itself, but to use some additional attributes like any text you can have from the image. And in order to get text from one image and to save the text as text, it's just a basic OCR for that. And for that, I am using Azure OCR capabilities. Okay, so this is this step. In order to get the main colors of a product, to get some automatic tags, I am using as well Azure Computer Vision for that. And I am using as well a Python library in order to detect any barcode or QR code from the image. And then you can consolidate everything, and everything will be saved into an Azure Cognitive Search index, because this is a perfect fit in order to manage all the concurrent search you can do. And everything will be available at the end. The endpoint will be an Azure Cognitive Search deployed index. So when you took a picture, an image, the first step is to convert it to a vec text. I will send this to the index. I will get the OCR, I will get the barcode, I will get all the results, and I can have a list of similar images rank from number 1 to top 10 or top 5. It's up to you. And then it's ready to use, and it's just a usual query, not only keywords, but using one image, and that will leverage additional attributes from the image using AI technologies available in Azure.
Well, this has been awesome how you took us through the whole journey from soup to nuts, beginning to end. Thank you so much for spending some time with us, Serge. By the way, this is the repo for those that want to see all the code that Serge just showed us. It's amazing. Thank you so much for being with us, my friend.
But thank you so much.
Awesome. We've been learning all about the Visual Search Toolkit with Azure AI with our friend Serge. Thank you so much for watching, and hopefully we'll see you next time. Take care. How about them apples? That was cool, right? I thought it was awesome. In fact, I have here, for those that may have questions, this is the actual visual search toolkit. I made it big so we can look at it together. Let's take a look. It's a cool way to bring a lot of stuff together. But you can see here's all the notebooks, the visual search. It has the things in there. Looks like it uses search, computer vision, Z-bar. What is that? Oh, barcode reader. Delightful. Z-bar, and then vector search. Oh, interesting. I've never heard of vector search. Image, text, video, and audio search using Azure Cognitive Search. Vector search. Ooh, look at this. Oh, this is Liam Kavanaugh. This guy is awesome. Liam, my dude. Yeah. This is cool. So this is how it does image search. It just compares the vectors. Oh, I see. The vector text. So this represents the image vector. And then what he does is he just compares the vector. So the closer the vector, the closer, I guess, the similarity. I guess. That's cool. All right. Then there's some images. There's settings, catalog, export. So it looks like you need to have these things. So here's the catalog of images. By the way, notebook rendering on GitHub is so much better than it used to be. Look at this. Look at this goodness. Look at it. Delightful. What kind of plots doing here? That's cool. What's SNS? Let's see here. Where's his import statements? Here we go. Oh, he's using Seaborn. I use Plotly. I haven't seen Seaborn. Seaborn statistical data visualization. Yeah, I think that's how all commercials should be. You literally just put this thing. It's like I'm in a big hall. Hello? Is anyone here? This is cool. So it looks like there's some visual. I might use this because I'm doing some research here. I might use Seaborn instead of Plotly. How about them apples? It's cool. He sets everything up. He looks at the architecture here. Looks like he's running this on a VM. Yeah, it looks like he's running this on a VM. This is cool. And looks like he runs this stuff inside of an Azure ML workspace. How delightful. Interesting. I wonder if this is just a straight like job. Yeah, it looks like this is just a straight job to set stuff up. Here's OpenAI clip. Wow, this is so thorough. How cool is this? Vec text generation, barcode information, Azure CD, OCR. This is cool. This is cool, by the way. Have you seen this new layout for GitHub? I'm a huge fan because it was always hard to, like, I'd have to go back and then do the thing, but now everything's in here. This is cool. So if I click on that, we should see a picture. These are called custom renderers. Because I do stuff. I work at GitHub now too. Did you know that? Here, let me show you. Boom! Boop, boop. Boop, boop. This is cool. Cool. So aka.ms, aka.ms, a visual search tool repo is right here. aka.ms/visual search toolkit. So go check it out. See if it does stuff for your business. If not, that's okay too. Alrighty. All right, so we have the last three things that we're going to do today. Let's start with a data generation tool. I'll explain it, and then we'll get into there and start fixing some things. Maybe we'll all learn a thing or two about how to do stuff in Python inside of Visual Studio Code, because it's actually way cooler than I ever thought it would be. Usually with Python, I always did print statements because I don't know anything, but now there's really neat ways to debug stuff inside of Visual Studio Code, so we'll work on that. So let's talk about the data generation problem. This is a tool, library, whose main job is to generate data. So let's go to the README here, and let me show it to you. Obvi still under development. Here, we'll kill this. Teaching machine learning things is hard. Let me, maybe, is this too small? The idea behind this library is to generate data in such a way that certain principles can be highlighted without resorting to finding the perfect data set to do so. So yeah, I like teaching stuff, and so love teaching machine learning, but it's always hard to teach specific concepts without having like the perfect data set. And I got tired of people drowning on the Titanic. So I didn't want to use it anymore. And for example, at Build, Microsoft Build, we had to talk about responsible AI. And how do you do that responsibly without like making racist or sexist or bad data sets, you know? And then making a model that's inherently terrible so that you can show how not to be terrible. And I couldn't do that. And so I built this library to generate data that's inherently biased against non-protected classes so as not to, pick an open wound scab, so to speak, emotionally. And so that's what this does. So Fibber is the name of the library. Fibber.io is the package, but Fibber because it's lying about its data. Little Fibber. And the way you use it is you call Fibber, you give it a task file, and then you give it an output, and you tell it how much of that data you want. That's it. Let me do a little zoom in here so you can see what I'm talking about. So again, you give Fibber a task file that represents the structure of the data you want to generate, the features, so to speak. And then you output the output file. It's like it's a CSV, and then you tell it how many you want. So this is, I want 10,000. You can give it, in theory, you could give it whatever number you want. And this is super useful for things like if I want to test machine learning, data diffs or data drift. And so that's the next thing I'm working on. How do I reliably with deployed models? How do I reliably create alerts in such a way that if there's data diffs or data drift, I can be alerted? Okay, so let's talk about how we describe tasks. There's two kinds of things. There's data that I can't generate and data that I can. So, for example, there is this section called sources and this section called features. I'm thinking of adding a section called post processing or adding noise, because obviously there's noise in all data. And so what this source says is that there's a named source at this path, and I'm just going to call pd.readcsv with these args. And then it loads it up into memory so that the features can pull from the source. So for example, the first feature is just going to pull from the names source, and it's going to pull first name. And then there's going to be another feature called age, which is distributed normally with this mean, standard deviation, and precision means how many decimal points. And then you can see the same. This is a continuous distribution. And then this one here is saying we have a feature named style. This is a discrete distribution to choose from these two things with these densities. Those are normalized to sum to 1. So you can put whatever number you want in there. So that's what this thing is. And today I'm going to remember how I did it and see if I can't add some features to it. So here's a question. Do you use Mastodon and GitHub? I've started using Mastodon. I'm still confused by some things about it, but I figured it's something I just got to pick up and learn. And heck yeah, I use GitHub all the time. GitHub is amazing. Okay, so sources and features. There's the key, path to file. This is the pandas read CSV. You can, in theory, put read _ parquet and then pass the argsv and it would work. The features are named. There you go. Distribution of the class. And then there's this notion of conditional distributions as well. Let me show you what that means. So here is a feature called age that's uniformly distributed, high, low, and then the precision is 2, so 0.00. And then this says if there is a conditional feature on the age. Let me zoom in because this is probably hard to see. So there's age. And this says if there is anyone aged between 14 and 65, not including 65, then the score is going to be a uniform distribution. Anyone that's 65 to anything else, normal distribution. Everything else that doesn't fit in those categories is a uniform distribution. So notice I'm forcing a conditional continuous probability distribution on top of a uniform distribution so as to create a dependency statistically on these features. So this is what this means. The score feature is conditioned on the age. Since the parent distribution is continuous, the conditional subdivisions should be represented by ranges. These are how you represent the ranges, the intervals, star, anything else. So it basically just puts these into a stack, tests them in order, and then when it gets to the star, it says, all right, I'll do that one if it doesn't match those things. It's pretty cool, and you can actually nest them further. So, for example, this conditional distribution called accepted works off the score. So it's a sub-conditional distribution. It happens recursively, and that's how that works. All right, thoughts on this? It's pretty cool. Pretty cool little library to generate things. One thing I noticed, though, is that this thing is very dependent on files. Like, for example, here's the conditional, one of the conditional ones that I did. This is very difficult to read. So the sources and features, that makes sense. This is the source to the names. But then the features get quite convoluted. So here is the name source, the age, farther, tabs versus spaces. So there's 4 features. But then there's, so that one's a simple one. That's a simple one. This one is not so simple. So this one has a uniform distribution with a embedded conditional. And so that's good. Okay, so that's good. Now let's take a look at this one. Oops, no. I'm wondering how many subconditionals this other one has. So there's conditional 1, score 1, and this also has a conditional. No, why does it keep doing that? So notice that tabs versus spaces has 2 embedded conditional distributions. I don't know. What do you think about this layout? Is it too complicated? Is this too complicated? There was a thing, a Jason tree. What does this do? No, this just beautifies it. How about this one? No, that one. Tree. Ugh. Or is it too simple? Yeah, maybe. I mean, the last thing I was going to add was so notice that we have features. I was going to add like a post-processing step to merge, because, for example, you might have 2 conditionals generate. You might have 2 features generate conditional distributions of the same kind of target, and so you'd need to merge them. So there's a merge, and then there's the also adding random noise to things, like this randomly flipping things from uh, discrete distributions, or adding uniform noise or noise from another distribution to continuous features. But I don't know. Is this the one? Yeah, I think this is what I wanted to do. Let's see. Or is it Jason Tools? I don't know. I never trust. Do you trust things that don't have an icon? I don't know. I have like a literal. I literally have like a. And instead I'm going, I don't know. Okay. Jason Treeview. Ugh. Because I think what happens is I guess I would be. If you freeze my frame, I could be made into an icon. It's true. I think what happened was when I did this, I had, let me just, there's only like, okay, let's do this one. Let's do this one. And then let's go to the, where's the tree viewer here? So JSON, and then I think maybe I need to restart this to make it work. Okay, what do we got? What do we got going on here? Oh, here it is, JSON tree view. Cool. So this is why I did this, because when you looked at the features, you could see these were the features, and then when you looked at the thing, you'd have the distribution itself, and then you'd have the conditional distribution that had the scores that were uniform. So this is why it made sense to me, because when you looked at it like this, it all made sense. I think that's why I made the tree look like that. So that when I'd go to this, it'd be like, oh, okay. So this is the tabs. This is going to generate tabs. But where's the conditional? See, that's the problem. Where is it? Oh, I see. Okay. Okay. So this is saying there's a score 1 that's going to be generated. If this is a tab, then we do if like it flows down. Okay. So that's how it's doing it. Okay, so let's try this out. But this time, let's test the task here to make sure everything is working. So we'll do this, and then we'll go to this testing thing. And this is what I'm telling you. Like Visual Studio Code is awesome because I did some. There's some tests in here using. Wait, how does it know these are even tests? It just knows. Oh, it's because it's under tests. There you go. And so it just reads these tests, which how does it even know? There's in it. There's the test range. Oh, it's PyTest. That's how it knows. So it's just doing PyTest. So if I go over here, right, and then I test the simple one. So let's do simple and hit debug. What this should do is it should go in here. Then I can F10, F11. It gets the path. So there's the task. Perfect. It loads the JSON. There's the JSON. You can see here. I guess we can take that off, take that off. We don't have very many breakpoints, but so you can see all of that stuff in here. And then I load the sources, and then it looks at the sources because that's the key for the sources. You can see that here. Notice that there's the name for each of the keys. If key is in the files, then it already exists. Otherwise, I get the item. I pop the path. There's the file path. Boom. I join to the parent path, resolve. It exists. And then I get the next item. I get the next item from the sources, which is going to be this read CSV. So I pop that and notice that the call that I'm going to make is read CSV. Then I create a pandas source with this call. So let's go in there. Look at this, man. I was super clever. Oh, you can't see me right now. Haha. Haha. There I am. It was funny. I was covering my face the whole time. Thank you. I always forget that that's happening. Let me put this chat here so that I'll remember. We'll remember. So we load the path up to the file. There's the path. You know, it's full names. And this is a really cool call because what I'm doing is I'm getting the attribute of the pandas library and I'm trying to get this call. So if I F10 that, notice that this is now a function, read CSV. If the args are greater than 0, they are, right? I'm calling it with, come on. These are the args. I'm calling it with encoding in engine Python. So I'm basically calling in essence, this is the exact same thing as me calling tab here. It's like me calling pd.read CSV, putting the path in there, path, comma, and then adding the args v, which are those two things, right? It's like introspection, I guess. There you go. I do it again. There's just one. Oh, I forgot to do the task. So now this data frame, if you look at it, should have 1,000 things. So if I go to the debug console here, you should be able to see df, boom. You can see all the data that it generated, which is cool. But I didn't go into that, so we'll step into that next time, which is right now. So let's go back to this, but instead of stopping here, we'll F11 into that. We'll go here, test simple, conditional, boop, and then F11. Oh, the other thing I did not do, okay, that was dumb, is show you how it loads the features. Dang. This is bananas. Because it's fully recursive that it does this. I don't know if I want to mess with it. I do know I want to add some rules for adding noise. And it looks like distribution. Oh, source. Why is this? Feature.pop conditional. If conditional and feature, else none. Grabs the next feature. Oh man, this is crazy. So this is actually instantiating classes in the distribution file. Wow. You know, sometimes it's like this is the source distribution. Jeez, look at this. You know, sometimes I feel like I'm too good of a programmer some days, and other days I'm looking at this, I'm like, who wrote this? 'Twas me. 'Twas me. And this sample, yeah. So notice this is the sampling. Okay, I know it. I see what I did. Oh, it looks like I'm using a more powerful random number generator too. Self RNG normal, self mean, scale, standard div. So when I say normal, and then these things are in there, that's what this is doing. Okay, so notice uniform. This basically creates the uniform class and passes these args into it, which is what you're seeing on the create side, because it's a static member of the distribution. There you go. Pulls the feature, gets the attribute, a class name, and then creates it with the keyword args. That's what it's doing. So basically, I'm treating these things as instantiate this class with these args. And so I bet if I were to take one of these off, it would fail and be like, you're missing parameters in your constructor. Okay. I don't know if I want to change that. To be quite honest. Well, no, I kind of do, because I think the problem. Okay, so here's the smell that I'm getting. The problem that I'm getting is that this task is generated by a file instead of so for example, I would never be able to construct one of these in code, which sounds wrong to me. It feels like that you should be able to construct it in code and then save it and then have like a static loader for the task, right? So right now, notice that this task, so this would be the static loader. Yeah, so there's, see, it looks like I started to do this. Can you have multiple constructors in Python? Let me see. Python multiple. Oh, here we go. Here we go. Okay. Oh, geez. I see what they're doing. This is dumb. So Python is interesting because there are two things you can add to a Python function call. Let me show you. Because I see what's going on here. Let me add a, I think it, let me do a test things.py. And then we'll move this over here. No, we don't need your PyCache. Delete. The PyCache is coming from, oh, I want it over here. The PyCache is coming because it, now you'll see that it should find it. Well, it's not going to find it until it gets in there. But there's test task. But if I go to test things, no, stop it. What am I doing? I just want to go to the, just want to go to it. Go to test. So, for example, if I go to test thingies and I go def, watch this. Boom. Test basic. Let's see. Oh, yeah. Notice that you'll see this is in here now, and it just kind of appeared, which is super nice. So when I run it, you'll see it'll be like, yeah, you're good. So let me show you. Let me show you how Python is like uber flexible. So def of my function, right? You can give it like names of things, or we'll do this. Print type of ASD. And then what we'll do, what's the deal? Okay. And then what we'll do is we'll call f of 1, for example. So when you run this, obviously the dumb thing is you're going to see it. Hold on. You'll see it here. It just does class of int. Right? But then you can pass it in like things like this. This will not work because there's a mismatch. But if you put a star in there, So let's do that. And now we run it again. It works. And you're like, well, what the heck is going on? That's weird, Seth. And when you look at the print of the type, it says class int. So let's actually go over here and debug this test so you can see what's actually when you put the star in there. Notice that ASD has all of these things, and it looks like it's a tuple of length 5. So if I were to say print ASD, now this won't work because it's already in memory, so I got to do it again. Oh, I got to debug it here. And then I hit F10. You'll see that it's printing out this tuple of stuff. It doesn't even have to be the same stuff, right? So if I were to do this again, oh, F5. You'll see it's okay with that. It's basically saying these are all the things that are coming in. So that basically allows you to pass in a set of thing into a function. You can also do this with constructors, which is kind of cool. So that's the star. I don't even know what that's called, to be honest. So now let me do 2 stars. This will break because now the thing doesn't take, oh, they're called positional arguments. There you go. But now it takes parameters of things. So let's escape that. And then let me show you something cool. Like you can say, A equals 1. There you go. Thank you. This will work. What? What is going on? Well, it turns out that this thing passes in a dictionary, right? Because when it sees these things, this is like one way of creating a dictionary. So now when I print it out, it's just a dictionary. This is usually called keyword args. What happens if I do this? Great question. Will this still work? Yes, it does work. And you're like, what? What's in args? Nothing. It's a tuple, an empty tuple. What's in keyword args? This one. Let me show you something else. You cannot do this, or can you? Let's see. So when I do this, you'll see that it'll be like, oh, it won't even. It's look at that. Even like it can't even do it. Like it not even a it won't even parse the thing. Control Z Z Z Z. Now, what if I do this? A comma. This will work. Or will it? Why did it work? Well, because we passed in A. Well, let me show you this, because this is and I was like, oh shoot, it's going to work because I forgot to do something. Notice that you're going to have the keyword args does not have A in it. The args has nothing and the A has 1. Now, if I were to do Z like this, let's see what happens. Let's try it. Boop. It's missing A, right? Okay. So this is why Python is so interesting to me, because it one is a dynamic language, but 2, I can pass any set. This will work now. Let me do A equals 1. I can pass in any set of things. Oh, sorry. I can do stuff like this now in such a way that I pass in the thing that's required. I can pass in a set of things, and then I can pass in everything else. So let's try that. Let's try that. Boop. So there's A. There's args, and there's keyword args. Now, why did I go through this entire detour to show you this? Well, because I discovered that in theory, anyone could write any distribution class at any time, include it somehow, so that whenever this thing comes in here, this would literally create that class with these parameters. And the way that you do that, is here. You get the class name. This pulls the keyword args. And then I get the name of the class name. I call class.create with the keyword args. And so I'm able to create any distribution class, which is really cool. I think that's cool, at least. And so that's how this whole thing is generated. So the question becomes, we have distributions. Should we be adding like noise things to this? I don't know. Okay, so what are your thoughts about this? What are your thoughts about this particular structure? Is it too complicated? Oh, and this thing, I wrote a parser for it. I remember now. Yeah, this uses a parsimonious to actually parse it so that it knows if it's right or not. And this is the BNF for it. Oh man, I was so precise about this stuff. I just didn't want people to put crap in there and have it not work, right? So this parses these conditional distributions, these ranges. Okay, and then looks like this is a abstract base class. This is something I don't understand about Python, mixing classes. I'm still trying to figure that out. Okay, so now that I've done this, let's take a look at this thing. Do we even need open-ended? No. And see if I want to add at the end of this, add noise things. Like, for example, notice this generates a score, but I think something else generates a score too. No. Yeah, see? This generates a score. This also generates score 1, and these things need to be merged together. And that, now I'm starting to remember. So what do I do here? All right. So let's go to my README and let's start writing some notes. Okay. Any other post things that we would do? I can't think of any. Oh, I can't delete there. Nerf. Blend columns with noise from this. Blend columns with addition. I don't know. Addition is just the opposite of subtraction, so we don't need that. So there was three. There was noise in the distribution, addition, adding two together. Okay. So I think it all boils down to blend columns with additions, and these additions would be either be noise, other features, and then maybe some remove columns. Okay, I think this is a good set of things to do this by. And by the way, in about 15 minutes, we're going to go back to Rochambeau and get that started up as well. But I needed to do this too because, like I said, I need to make some samples that do data drift samples is what they're called. So if we were to add, let's make a new one. Let's do some simple ones. That way it makes more sense. No. So we're going to add some new data. Oh, this was here. Very nice. This was a flat. Was this flat? Let me see. Yeah, what we'll do is we'll make a flat one like this. C, Control V. And then we'll make this a rename people post. So what we'll do is we'll get rid of all the conditional stuff just because I don't want to mess with that just yet. So we'll take that out. Oh, geez, that's the problem with this stuff. I wonder if I can just... Cool. So this gets stuff from the source. This also gets stuff from the source. This gets stuff from this. You know, I don't know if I want to do that. Because I mean, we already know this works. So this is two subconditionals. Two subconditionals. Okay. Okay, should we call it post or what should we call it? Timer for 15 minutes.
15 minutes, counting down.
Thank you. Post, or should we call it process or process? Okay. So, oh wow, this is clever. What's it even doing? Under the process step, we are going to need, where's my notes? Notes, here we go. Add noise. Okay. The other question is, when we're doing this, there's like these columns, right, of stuff. The question is, when I add noise to a column, so for example, this operation just adds stuff to a column. This operation that's a repeat. So again, with our stuff here, This so blend columns with it. So a noise addition does not require other columns. So you might have like boom from some distribution just generates this thing. Right? Cool. So we need to know, does this do this in place or does it generate a new column? So it looks like there's a post process and then a clean setting, because my sense is that you're going to have all these columns and then you're going to want to clean out columns. Okay. So the question is, do we do these things in place? It's a good question. I don't think we do things in place. I think we create new columns with new names that have the additions. Because sometimes there's going to be addition. There's going to be two things. So there is the source feature, right? And then there's going to be a target. But the source might be two. No. Okay. Cool. Okay. So we're going to have the source, and inside of the source, I got to back this up because there's not enough. So I'm literally writing stuff down. Ideas. So let's call one, call two. Boop. I think it's like this. Is this how you do tables? And I don't even remember how to do tables anymore. Oh, jeez. I'm going to have to look up how to do markdown tables because I'm a goober. Markdown tables. How to mark down a table. Beep, 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 beep. I was close. Don't judge me. Okay. So call one. Call two. Call three. Okay. First idea. All column changes are additive. We will create a new. Hold on, I got to do something real quick. Oh, Teams died on me. Oh, okay. Columns for each op. Can only work with two things at a time. i.e., can work with feature plus distribution for noise, or feature and okay. Cool. Post-gen tasks. Okay. So it looks like these are two different tasks here. Blending columns and removing columns. Column blending. Feature plus distribution. Adding uniform noise to call to. This would be post is what we're calling it now. Okay. Adding call post. So okay. So we're adding noise to call to. Call. Oh, shoot. I guess we'd say call to. And then we describe what we're doing to call to. This works, right? The question is, how do we do this deal, though? By the way, if you want to use this stuff, you just need to do a Fibber IO search, and you can find it on PyPy. So yeah, if you're interested in that, you can totally just use what's there now, right there. Oh, look at that. Janice had some good ideas on how to do the columns, but I was not paying attention because I was deep in thought. So this is the question. So the thing about this, though, is there's two problems. Now that I'm a PM and I don't work in DevRel anymore, I write everything down. So, like, if I have an idea and I'm like, this was it, then I write it down. Oh, see, this is clever because if I have a discrete or continuous one. Well, no, this would not work. I'd have to treat NANs, NANs, and nuns. So if there's one case where this does not work, is where we would put a none in, but none is discrete and continuous. Zero is, I don't know. So yeah, for example, missing values would allow me to add missing values. So when I'd add a column, I could randomly generate a list of missing values with an appropriate density, and then just add those in, which would be cool. But that would be a special edition. That would be like a NAND generator. Okay, so we have the target, call to noise. Column 2 is numeric. So what would have to happen is you would have to have your distribution, and this we would get out of some of this. Why is it doing 4 spaces? Let me do 2. Well, that didn't do anything. Okay. So this means we would need a source, a target, and an operation. Okay. So source would be this normal distribution. Mm-hmm. Something is very wrong. There you go. So the source, we're working on column 2. The source for our data is going to be this distribution. The target is going to be this thing, and then we need an operation. Right? And it could be something like add or subtract or divide or whatever. Or left blend or right blend or something. Okay. So add, subtract, 3, multiply, 4, divide, 5, custom, A, op, B situation. So just anything, which leads to continuous thing. Okay, these are interesting, right? Because how do you add 2 discrete values? So I'm guessing this is tough. So we'll leave this for now. Let me check this in, and we can start to look at this a little bit later. So we can get, first I want to get back to Rochambeau. Okay, where? Oh, sorry. Why can't I zoom in or out anymore? Oh. There we go. So let's close this and let's check this in. Get status, get add dot get commit minus M. I'm doing semantic check-ins. Semantic check-in. December. Poetry. Okay. So I promised I would do this because type, scope, subject, body, footer. It's not a fix. Docs. Okay, git commit minus M docs post process. We'll call it post process. Post process added general thinking for feature feature addition semantics. Git push origin dev. Boop. All right, and if we go to github.com, Seth Juarez, and then Fiber.io, you should be able to see it in there, which is nice. Dev. And so under notes, you'll see this stuff. All right. Okay. Hello, my friend. Hello. I'm getting so old. Aniket Ranjan, welcome, my friend. Welcome, my friend. All right, let's get back to Rochambeau here. File, open recent, Rochambeau. Looks like we made some changes. What did we do here? Doot. Oh, yeah. Huh. Oh, yeah. We added the... oh, this is cool. Oh, snap. Let's take a look. I think it was yarn.dev. Yarn. Oh, we got to go to web. CD web. Yarn dev. Timer for 18 minutes.
18 minutes, counting down.
Thank you, sir. Okay, so we not here. Where did we put it? There's Fibber.io. We want to open this thing. Thank you. And then we had, it was train, I think. Okay. Hello. And I think, or none. Do I press space? Was the space bar working? Oh, shoot. Oh, okay. Now I see so now I see what we're fixing. Like when I press the space bar, it only fixes. Okay. Oakley dokley. Let's go to train.tsx. When I do the space bar, it calls add image. If e.key equals space, add image. If there's a current video ref, it says frame, and then it grabs the images and adds one. So why isn't it adding another one? But it is on the button. All right, let's see what the button does. El botón. This calls add image. Yes. What's your dealio, man? You little bugger. No, it's not doing anything. I feel like there's some deal here. Handle key. Add image. Gets the current frame. Set image. So something's wrong with the set state. Set images. So it gets all of the images currently in there and adds this one. So this is a spread operator. JavaScript, man, and its goofy operators. They're not bad. JavaScript spread operator. Yeah, it's just expanding it out, which is what I want, right? Because it's basically saying, I want all the other images spread out in this array and then add this one. But it seems like it's not adding it. And this is. F strings in JavaScript are interesting, are they not? Let's do an F string here on set images here. Okay, so let's go back to this thing. We're done with you. Here we go. Let's refresh this. And we'll hit the space bar. Looks like there's nothing in the current set. Remove that. Let's do dot length. Not Jason, you goober. All right, let's see what we got going on here. Okay. Spacebar. No. See, that's weird because it says there's nothing in the set, but when I go like this, notice that it does have something in the set. It's why it keeps doing that, because for some reason it may be capped. I think what's happening, it's got to have to do with the closure. I think it might be closing over this thing too late. Let's try this. That is so weird. It's the problem is this. It has nothing in here. And then, but still, if you add nothing to an empty spread, that is weird. See if it sees this here. Of course it sees that. Let's try it. Yeah, see? Well, what is that, though? What the heck? Freaking JavaScript, man. See how this works? Oh my gosh, what are you doing? Where does it have where it stores its values? Because this is tough. Trying to figure out, like, why is it that... Where does it store its memory? I don't know. Oops. Oh, geez. That's another thing I need to fix. This does not look good in Where does it store its memory? Components. Oh, excuse me. I'm wondering why. So there's the state. What is this component here? Head default, navigation, device selector, anonymous, footer, device selector, anonymous, forward ref, footer. Where's this thing? Here it is. So here's all the image state, which is great. So if I take this off, oh, I guess I can't, but if I do this, this should be empty. Oh my gosh. This is ridiculous. Why is this stuff so hard? I broke it. I am Batman. Well, how about them apples? At least, yeah, this is just weird. This is weird for me. Under train, you'll see that the state is in there. There's the ref for getting the frame, and there's the image state. That's weird. All right, so whoa, run out of time here. So what I want to do is I'm going to figure this out because this is just weird. I basically want to get to a place where I hit the space bar and give it a bunch of images. So like it'll just, keep going. And then at the top there'll be like a button that says submit. And what this does is this will send all of the pictures up, put them in blob storage so that at subsequent training, model trainings, it'll have better images. And the idea is that if it's public, you should be able to also go and put images of yourself in there, but I'll have to add some checks into it using Cognitive Services to make sure there's nothing improper. Which is great. And then I think I need to redo the layout here because the layout looks kind of garbagey. No me gusta. No me gusta. And then maybe I'll spend like a day or two on it, like actually making it more polished because I only work on this stuff, when oh shoot. I only work on this stuff when with y'all. Every once in a while though, I do extra stuff, but not all the time. So I gotta put my walkout music here. Next time on the AI show, we are going to be. Oh, looks like Peggy put it in the chat. Thanks, Peggy. We have a great show coming up. Rob Nunez and Albert Dankwell will host, and they'll be talking about AI Builder, which is great. It's this thing right here. So make sure you come for that. It's going to be delightful. On a side note, obviously we'll continue to work on this stuff until it works, and you all can play with it as well. Rochambeau.ai. Also, the other thing that I just recently heard is that the Azure Static Web Apps will take Next.js projects and render the API side without having to create a separate Azure function as part of Azure Static Web Apps. So that's also cool. So I'm looking forward to that. I might try to deploy Rochambeau.ai to a non-app service and just deploy it to an Azure Static Web App. I'll do the same with my website. So that's pretty cool as well. As always, if you have any questions or want to get a hold of me, I don't think I've ever done this. So let me. You can reach me on my email. Let me type it in here so y'all can see it. Seth.Juarez@Microsoft.com or on Twitter. I don't know. Twitter's getting kind of. I don't know if I like it anymore. That's where you can find me. On the email, seth.juarez@microsoft.com, or on Twitter, Seth Juarez. As always, I love your questions. If there's something you're working on that you'd like to talk about on the show, some people have actually reached out to me on that. Let me know. You can, again, reach me at Seth Juarez or Seth.Juarez@Microsoft.com. As always, it's a privilege and a pleasure to be with every one of you for this little bit of time. Thank you so much for watching, and hopefully we'll see you next time. Take care. Until the next time.